Okay, time for some more therapy. Let's see. Those are beautiful sand dunes, aren't they? And let's see, a lot of things going right with me right now. I mean, for example, I've got my new merchandise concepts coming out. Yeah, those are some cool concepts. Those would look good on a t-shirt or maybe on a coffee cup. Plus, I've got some new ideas coming in that may be even better. So, yeah, let's get back to these sand dunes. I always find this stuff so relaxing. Now, let's go ahead and read some things that I like. Space.com. I really enjoy that website. Oh, what's this article about? Perchlorates in the Martian regolith. Oh boy. Okay, so what does it say? The high levels of perchlorate found on Mars would be toxic to humans. Anybody who is saying they want to go live on the surface of Mars better think about the interaction of perchlorate with the human body. At 0.5%, that's a huge amount. Very small amounts are considered toxic, so you better have a plan to deal with the poisons on the surface. Wow, that's really dramatic. Any humans exploring Mars will find it hard to avoid the finest of dust particles. It'll get into everything, certainly into your habitat. Now wait a minute. Are you saying that there's absolutely no way for us to mitigate this stuff? And is it really that toxic? I mean, is it just pure poison and nothing else? Okay, take a deep breath and let's see, another article. This one's dated 2017. Mars' surface is looking much deadlier than we previously thought. A new study has revealed that compounds present in the Martian soil can wipe out whole bacterial cultures within minutes. Researchers have had their suspicions over whether microorganisms can actually survive on the surface of the red planet, and now lab tests are spelling doom for any potential little green bacteria. And yeah, growing potatoes on Mars, oh, they like that one, don't they? Might be more difficult than we thought. Okay, screw this. Is any of this actually true? Are all microorganisms killed instantly by this? I mean, these articles would have us believe that the surface of Mars, coming into contact with it is like jumping into a vat of cyanide. I mean, is the surface of Mars really this deadly? And is there absolutely nothing that we can do about it? And more importantly, is there a way that we might actually be able to use the Martian regolith to our advantage instead of avoiding it like the plague? Good evening, and welcome to another episode of The Angry Astronaut. As you can see, we finally have audio, or at least something resembling it, thanks to the assistance of our Patreon supporters, and I really appreciate your assistance in making this possible. I have no idea if this is going to be our final solution, but nevertheless, it should make the difference between you listening to me here and the voiceovers a little less jarring. So we'll see how everything goes. But in any event, thank you so much to all of our Patreon supporters who are being recognized on the screen right now. And the topic of this particular video is the direct result of the input of one of these supporters. Because I've always regarded the Martian soil and the Martian regolith as being something exclusively negative. Poisonous, deadly to colonization, and it has to be bypassed with some sort of food production that does not involve the use of soil. But what if I were to tell you that the Martian regolith can be as much of an advantage to Mars colonization as it can be a drawback? And this is something that's almost never talked about in the mainstream media, and I have to admit, it really pisses me off. And by the way, if you want your ideas to be showcased on this particular channel as well, then by all means, become a Patreon member, DM me, and I'll be more than happy to review your ideas. And you may find your way onto my channel. I certainly hope so. Keep in mind, I also review all the comments that are made by non-members and come up with a lot of ideas there too. So you don't necessarily have to be a member, but it allows you to participate in the weekly Q&A sessions, and that's where I'm starting to get a lot of my ideas. That's enough of that. So, what are these perchlorates? Why do they represent a problem? And how might we use them to aid in our efforts to colonize Mars in a way that other planets just don't have to offer? Sit back and get ready for some interesting information. So what are these perchlorates and where do they come from? Well, interestingly enough, they're comprised of 4 oxygen atoms and just 1 chlorine atom. So a whole lot of oxygen, really, and yet they tend to be pretty toxic nonetheless. But how do they come into being? Well, that's a matter for some debate, but there is a pretty compelling theory. It is thought that the electrostatic nature of, you guessed it, my favorite topic, Martian dust storms, create electrostatic discharges which can create these perchlorates. As a matter of fact, when researchers conducted electrostatic discharge experiments within Mars-like temperatures and atmospheric pressure inside of an enclosed chamber, they found that interactions between the discharged electrons and the molecules similar to Mars instantaneously generated free radicals, which then oxidized the rock salts to create chlorate, sodium carbonate, and of course, perchlorates, and in very large quantities. Louis Derry of Cornell University said, quote, "The study presents a very interesting mechanism for generating these highly oxidized compounds on the Martian surface. It has been difficult to achieve the apparent rate of production needed to explain the high abundance of these compounds on Mars using the same mechanism that operates on Earth, largely because the Martian atmosphere is too thin." This theory seems to be further supported by the fact that only the top half meter or so, perhaps even less, of the Martian soil seems to be contaminated with these perchlorates. So, all an intrepid Martian explorer would have to do is dig a hole, what a tough task that would be, and then use the soil beneath it for planting potatoes, so long as the soil was properly fertilized with his own feces, and that feces was properly decontaminated, something that any good botanist would be able to do. The Martian really is not that unrealistic, as lots of people like to think. So what makes these perchlorates so dangerous? Well, here's what the paper entitled "Perchlorate on Mars, a Chemical Hazard and a Resource for Humans" has to say. Quote, "Perchlorate is a health concern because it can impair proper functioning of the thyroid gland. By competitively inhibiting the uptake of iodine ions, thereby hindering hormonal output. Thyroid hormones are responsible for regulating mammalian metabolism. A long-term reduction in iodine uptake in an adult can ultimately result in thyroid hyperplasia, decreased metabolic rates, and slowing of the function of many organ systems." However, the paper goes on to point out that the competitive effect of perchlorates on iodine uptake is reversible once exposure to these perchlorates ceases. However, this is not to say that perchlorates are harmless or not a serious concern. Inhaling them is especially problematic. Because Martian dust is so fine, so tiny they cannot be expelled by human lung mucus. As a result, inhaling just a few milligrams of dust would bypass the human mucus system and be absorbed directly into the human bloodstream. And this could be very problematic, especially during a dust storm or if astronauts were to bring the dust inside with them through an airlock. Now, the solution to this problem could be pretty obvious. Either have the astronaut suits directly tied into the habitat so that they don't actually enter an airlock and the suits remain outside the habitat at all times, or a washdown spray could be used to clean suits and equipment with dust deposits, and then the dust would be drained away, and a separated process could recycle the water and decompose the perchlorates into usable oxygen. On top of that, you could use vacuum systems with air-purged filters, electrostatic cleaners, and other technology that's similar to what's used in modern mining systems. Now, if humans were foolish enough to grow food in perchlorates, that could be a problem too, as the perchlorates would contaminate the food, it wouldn't even grow very well, and would also poison anybody who would be unfortunate enough to eat it. So any soil used to grow food would also have to be cleansed of perchlorates, at least the top few centimeters anyway. And why would we want to bother doing this? I mean, doesn't aquaponics or aeroponics make a whole lot more sense? Well, not if you're interested in breathing. If you were to break down all the perchlorates in 60 kilograms worth of regolith, you would come up with 550 liters worth of oxygen, which would be enough for one astronaut for an entire day. So not only would you have soil necessary for agriculture, but you would also have oxygen, which is pretty damn important for human life. Also, oxygen can be used for solid rocket fuels, and there would be a number of ways to break down the perchlorates besides just washing it out. There are no less than 50 different types of bacteria that can naturally break down perchlorates and use them to their own advantage, and we can duplicate that process by using different types of enzymes to clear the perchlorates from the soil, once again providing oxygen for both breathing and for solid rocket fuels in the process. As a matter of fact, the clever authors of this particular paper came up with a portable emergency oxygen system that provides an astronaut with 1 hour of breathable oxygen using perchlorate decomposition catalyzed by enzymes which are extracted from perchlorate-reducing bacteria. So the astronaut would just collect 6 kilograms worth of Martian regolith, add water, it would dissolve it, and carry the highly soluble perchlorates into a container holding the enzymes, and the oxygen would be directly fed into the astronaut's suit. Pretty damn useful. So what can you grow in this stuff once you clean out the perchlorates? Well, once it's fertilized with compost, which would be generated by aeroponics or hydroponics, you definitely need those kinds of systems no matter what. But once fertilized, just about anything will grow in it. Simulated Martian soil, according to a research team from the University of Villanova, was able to grow just about any plant they put in it. As a matter of fact, sweet potatoes, carrots, onions, kale, dandelions, basil, garlic, and hops were particularly robust and tasted and behaved almost precisely like their Earth equivalents. Future teams intend to test a more healthy cross-section of vegetables and possibly even fruits as well to determine what would be the healthiest diet for future Martian colonists. So when it comes right down to it, the perchlorate-laden Martian soil gives us oxygen, it gives us fuel, and it gives us food, and it can give us something else. That's right, trees. And before you start laughing, keep in mind that if you're looking to sustain 1 million people on Mars for the long term, this is a damn good way to do it. This particular biodome is designed to support 100 people, both in terms of oxygen and all of the food that they need to survive for the long term. It contains almost 200 apple trees, over 11,000 potato plants, over 285,000 rice stalks, and over 66,000 soybean plants. Now, if that sounds absolutely impossible, it isn't. All of these plants can be contained in an area that's smaller than the size of a high school jogging track. The only drawback to this system is that human beings won't produce enough CO2 to support the plants, so you would actually have to pipe in carbon dioxide from the Martian atmosphere in order to keep the plants going. It's quite a remarkable system and completely capable of supporting 100 colonists without any other source of oxygen or food supply whatsoever. But where do the people live? Well, that's an interesting question that has an interesting solution. A NASA award-winning plan from MIT proposes that we use an inflatable cellular membrane to protect the biodome, and everybody lives beneath it in underground dwellings protected from the radiation. On top of that, this is a cellular membrane with each cell containing water, providing additional radiation protection. So it's the best of both worlds: surface dwelling and easy access to the surface, along with subsurface habitation and complete protection from Martian radiation. Now, if this seems too long-term for you, here's another idea: bamboo. It's incredibly resilient, capable of growing under a variety of different circumstances, and as long as the soil was cleansed of perchlorates, it could grow on Mars. In 3 years, enough bamboo could be grown and then woven together by robots in order to create these sorts of habitation structures. And as long as there was enough water on site, the water could be pumped into the structures and then frozen, providing additional radiation protection for the residents inside. And here's an interior diagram of just what this would look like and how many different features it would have. A very ingenious idea and a great alternative to 3D printing of Martian regolith. So we've got food, we've got oxygen, we've got building materials, we've got rocket fuel. I mean, what's not to like about this? Oh, and you remember how I said that there were 50 different types of bacteria on Earth that naturally use perchlorates and break it down into its component molecules, including oxygen? And also, have you heard that we've discovered a lot more oxygen in the Martian atmosphere than we thought possible? It may be that what we need to clean the perchlorates out of the Martian soil may already be there, and we just need to give it an extra helping hand. So prior to this video, I always looked upon Martian food production as being something that we would have to employ by not using the soil, whether it be aeroponics or hydroponics, something that would avoid these deadly perchlorates. But now that I've had an opportunity to review this information more thoroughly, I've come to the conclusion that I may very well have been wrong. In fact, I'm convinced that I'm wrong, because there are certain kinds of plants, particularly trees and other large forms of plants, that are very difficult to grow with these kinds of methods. And not only that, these methods also require a great deal of energy. Whereas a massive greenhouse full of trees, bamboo, etc., they can be supported by the sunlight. Even though there's less sunlight on Mars, concentrated solar panels can solve a lot of those problems. And then we can diversify the types of food that we have at our disposal. And the more diverse our diet, the better, in my opinion. Plus, it encourages Martian colonists to move to the surface. I know that most of you realize that I'm pretty prejudiced when it comes to that, but we are a species that is not nocturnal, that does not spend most of our time in the caves. We have always evolved on the surface, and we are diurnal. That being the case, going to Mars is going to be a hardship in itself. It's going to be so difficult in so many ways. Do we really need to change our basic nature as well? I say no. I say there are ways around that to make our colonization of Mars an easier task, both psychologically and in other respects, that will provide us with a much better chance of success in terms of establishing a self-sustaining presence on another world. But there are those who disagree with me, and who knows? As far as I'm concerned, have at it. In the future, they may be two different kinds of humans on Mars, like the Morlocks and the Eloi of the Time Machine, for those of you who are familiar with that particular classic tale, although I sure as hell hope that it doesn't turn out that way. But until we get to that point, and until we're growing trees on Mars and converting this poisonous planet into something that is both beautiful and suitable for human habitation, I encourage all of you to stay angry about space.